In the late 2000 teens, Britain had an uncomfortable problem it rarely talked about in public. North Sea oil and gas were fading, export strength was thinning, and the country's long-running argument about how to replace industrial heft with services had started to feel less like strategy and more like wishful thinking. Then, almost unnoticed by the public, a project appeared that promised to do something unfashionable but very concrete: dig something out of the ground and sell it to the world. Not shale gas, not lithium hype, not some speculative green miracle, but a mineral most people had never heard of, pulled from almost a mile beneath a national park. The pitch was simple and deliberately dramatic. This single resource, polyhalite, could add the equivalent of roughly $130 billion to the British economy over the next half-century. That number was not whispered by activists or bloggers, but repeated by the companies and agencies backing the project. It was framed as a quiet economic reset, a long-duration export engine, and a rare example of Britain still playing the heavy industry game on a global scale. The twist was that almost no one could see it happening. Drive through the countryside near Whitby in North Yorkshire, and you would not pass steel towers, truck convoys, or the usual visual clutter of a major mine. Instead, you would see fields, hedgerows, and a few barn-like buildings that look as if they belong to a farming cooperative. That is the point. The Woodsmith Project, as it is formally known, sits inside the North York Moors National Park, one of the most tightly protected landscapes in England. The deal with regulators and local communities was blunt. If you want to build a mine here, you hide it. Almost everything happens far below ground, deeper than any mine in Europe. This is where the narrative becomes deliberately provocative. Britain, a country often accused of exporting pollution while outsourcing production, is quietly building one of the deepest and most complex mines on the continent and marketing it as low impact. The infrastructure that usually signals extraction, the noise, the traffic, the concrete, has been pushed underground. The project's supporters call it responsible mining. Critics call it clever optics. Both can be true. At the center of the story is polyhalite itself. Unlike oil or gas, it does not promise quick profits or geopolitical leverage. It promises something less glamorous, but more stable: fertilizer. In a world where food security and agricultural inputs are under constant pressure, that alone is enough to get policymakers interested. The mineral contains potassium, sulfur, magnesium, calcium, and trace nutrients in a single naturally occurring package. It does not need chemical conversion to be useful. Crush it, granulate it, ship it. That simplicity is repeatedly emphasized because it underpins the project's main selling points: lower processing emissions and a product that fits neatly into the growing market for natural inputs. From the start, the Woodsmith mine was framed not as a local curiosity, but as a long-term national asset. Its backers talked about 50-year horizons, global markets, and steady export flows rather than boom and bust cycles. The implication was clear. Britain might argue endlessly about services versus manufacturing, but here was a reminder that geology still matters. Sometimes, the most disruptive economic story is not a new app or financial instrument, but a hole drilled deep enough to change what a country sells to the rest of the world. Polyhalite sounds obscure because, until recently, it was. For decades, global fertilizer markets revolved around a familiar trio: nitrogen, phosphorus, and potassium, usually processed through energy-intensive chemical routes. Polyhalite does not fit neatly into that model. It is a naturally occurring evaporite mineral that already contains potassium, sulfur, magnesium, calcium, and multiple micronutrients in one crystal structure. There is no need to synthesize or chemically recombine its components. Once mined, it is crushed and granulated, then sold largely as is. That single fact explains most of the enthusiasm surrounding the Woodsmith project and also much of the skepticism. Supporters frame polyhalite as the anti-fertilizer fertilizer. Traditional products often depend on fossil fuels, especially natural gas, and leave behind soil damage over time. Polyhalite, they argue, feeds crops more slowly, improves soil structure, and avoids the chemical shock associated with conventional inputs. The marketing pitch goes even further. Crops grown with it can, in many jurisdictions, be labeled as organic compatible. For farmers facing consumer pressure and regulatory scrutiny, that is not a minor detail. It is a potential pricing advantage. Anglo American, the company now in charge of the project, brands its polyhalite product as Poly4. The name is blunt, almost industrial, and intentionally avoids green poetry. The message is that this is not a miracle substance, but a practical one. Same price range as standard fertilizers, fewer environmental headaches, and simpler logistics. In fertilizer markets, where margins are thin and volumes are massive, good enough and reliable often beats revolutionary. Still, the claims deserve scrutiny. Fertilizer demand is global, but it is also brutally competitive. Potash producers in Canada, Russia, and Belarus dominate supply chains, and farmers are famously conservative buyers. They do not switch inputs because of branding. They switch when yields, cost, and reliability line up. Polyhalite has shown promising results in trials, particularly for high-value crops, but it is not a universal replacement. It works best as part of a nutrient mix, not a silver bullet. That nuance rarely makes headlines, but it matters for long-term adoption. This is where the Woodsmith narrative becomes more strategic than scientific. The project is not betting on polyhalite replacing existing fertilizers overnight. It is betting on incremental substitution at scale. Even capturing a small percentage of global fertilizer demand translates into millions of tons per year. For a mine designed to operate for generations, that slow burn is not a flaw. It is the plan. There is also a geopolitical undertone that rarely gets stated directly. Fertilizer markets are sensitive to sanctions, wars, and trade disruptions. Recent years have reminded governments that food supply chains are not immune to politics. A large, stable, domestically controlled source of multi-nutrient fertilizer fits neatly into the language of resilience and strategic autonomy. Britain may no longer talk about empire, but it still understands leverage when it sees it. The irony is that this leverage comes from a mineral most people cannot pronounce and will never see. Polyhalite will not change consumer behavior or inspire environmental movements. Its impact, if it works, will be quieter. Slightly better soils, slightly more predictable harvests, and a steady stream of bulk ships leaving a northern English port. That is not a glamorous future, but for an industry built on margins and reliability, it is exactly the kind that lasts. What ultimately makes Woodsmith more than a clever sustainability story is the sheer scale of what sits underground. According to published resource and reserve estimates, the polyhalite seam beneath North Yorkshire is measured in the billions of tons, with a thickness of roughly 70 meters and lateral continuity that mining companies describe as unusually consistent. This is not a narrow vein that demands constant geological guesswork. It is a broad, predictable layer formed when an ancient sea retreated hundreds of millions of years ago, leaving behind mineral deposits that today look almost engineered for modern extraction. For analysts, those numbers are the real headline. A resource base counted in multiple billions of tons translates into mine life measured not in decades, but in generations. Company filings and technical presentations consistently point to operating horizons approaching a century. That matters because it changes the investment logic. A project like this is not built to chase a commodity cycle. It is built to survive several of them. When management talks about long-term value, this is what they mean in practice. The quality of the deposit strengthens that argument. Independent testing and company disclosures put the purity of the polyhalite at close to 90%. In mining terms, that is unusually high for a bulk mineral. High purity reduces processing complexity, lowers waste, and cuts operating costs over time. It also underpins the claim that the product can be marketed as lower carbon compared to fertilizers that require extensive chemical transformation. Again, this is not a moral argument. It is a cost structure argument dressed in environmental language. The scale also explains why the project keeps being described as Tier 1. In industry shorthand, that label is reserved for assets that combine size, longevity, and competitive position. Woodsmith checks all three boxes on paper. The size is there, the longevity is clear, the competitive position depends on execution and markets. But the geological fundamentals are difficult to dismiss. There are no other known deposits of polyhalite on this scale currently being mined anywhere in the world. That exclusivity alone attracts attention from investors who normally ignore fertilizer projects. Still, size cuts both ways. A deposit this large demands equally large infrastructure, equally patient capital, and an equally long tolerance for delays. Unlike smaller mines, Woodsmith cannot quietly scale back if markets soften. The tunnels, shafts, and processing systems are built for volume. If demand disappoints, the fixed costs do not disappear. This is the structural risk embedded in every megaproject, and it is not unique to Britain. What makes Woodsmith distinctive is where it sits in the national conversation. Britain is not known for betting on geology anymore. It is known for betting on finance, property, and services. A multi-billion-dollar mining project forces a different mindset. It asks whether the country is willing to commit to slow, capital-heavy industries that do not fit neatly into quarterly narratives. In that sense, the polyhalite deposit is more than a mineral resource. It is a test of whether Britain still has the patience required to turn deep time into long-term economic value. The phrase invisible mine is not a metaphor at Woodsmith. It is a design requirement. Because the project sits inside a protected national park, every visible element became a regulatory problem to solve, rather than a feature to showcase. The solution was architectural camouflage paired with extreme depth. Instead of headframes and processing plants rising above the landscape, the surface facilities were designed to look like agricultural barns, deliberately low profile and surrounded by existing woodland. From a distance, they blend into a landscape already shaped by farming rather than industry. Most of the action happens far below. The main shafts plunge to depths of around 1.5 kilometers, well beyond the reach of normal sight and sound. Workers, equipment, and eventually mineral all move vertically through these shafts, sealed off from the surface. There are no open pits, no waste rock piles, and no fleets of trucks rumbling through nearby villages. For regulators and local communities, this mattered. The promise was not just reduced visual impact, but reduced daily disruption. This approach is often presented as a triumph of modern, responsible mining. There is some truth to that. By pushing infrastructure underground, the project minimizes land take and preserves surface ecosystems. It also avoids a political headache. Open confrontation with environmental groups would have delayed the mine indefinitely. Designing it to be almost invisible was as much about social permission as it was about engineering. The company also backed this strategy with money. Tens of millions of pounds were committed to local investment, skills training, and community programs. A familiar pattern in modern resource projects. Critics dismiss this as the cost of buying goodwill. Supporters call it economic participation. Either way, it is part of the operating environment. Large mines no longer exist in isolation. They exist inside negotiated social contracts. Yet there is an uncomfortable question beneath the barn roofs. Does hiding industrial activity make it more acceptable, or simply easier to ignore? An invisible mine is still a mine. It still consumes energy, capital, and labor at scale. It still reshapes supply chains and local economies. The difference is that its footprint is psychological as much as physical. People who never see it rarely think about it. This invisibility also shapes public debate. Without towering structures or obvious scars, the project avoids becoming a symbol. There are no viral images of destruction to rally against. But there are also no dramatic visuals to rally support. The mine exists in planning documents, technical reports, and investor presentations rather than in everyday life. That suits a project built on long timelines and quiet returns. In this sense, Woodsmith reflects a broader trend in heavy industry. Modern projects aim to reduce friction, not just emissions. They design out conflict by design. Whether this represents progress or simply smarter politics depends on perspective. What is clear is that the invisibility of Woodsmith is not an accident. It is a calculated response to a country that wants the economic benefits of extraction without the visible reminder of what extraction looks like. If the surface of Woodsmith is about discretion, the underground is about brute precision. Two main shafts form the backbone of the operation, each sinking to depths of roughly 1.5 kilometers. One is designed primarily for people and equipment, the other for the mineral itself. This separation is not cosmetic. It reflects the reality of modern deep mining, where efficiency and safety depend on tightly controlled vertical logistics rather than improvisation. Sinking shafts to this depth is not routine, even by global mining standards. The process relies on mechanized shaft boring systems rather than traditional drill and blast methods. These machines cut the rock in measured increments, lining the walls with reinforced concrete or steel as they descend. The goal is stability over speed. At these depths, minor errors become expensive very quickly. The engineering challenge is not just reaching the seam, but keeping the shaft usable for decades under enormous geological pressure. Once underground, the mine is expected to evolve into a vast network of tunnels and extraction panels spreading over thousands of square kilometers of subsurface area. Polyhalite is extracted using a combination of controlled blasting, mechanical cutting, and drilling. From there, the ore is transferred onto flexible conveyor systems that feed directly into the production shaft. Unlike older mines that rely heavily on haul trucks, Woodsmith is designed around continuous movement. The mineral moves almost constantly, reducing bottlenecks and labor intensity. At the top of the extraction shaft sits a hoisting system capable of lifting large volumes of material from extreme depth. This is where the mine's scale becomes unavoidable. The hoists, hidden inside barn-like buildings on the surface, are comparable in size and power to those found in the world's largest mining operations. Their job is simple to describe and difficult to execute. Lift millions of tons of rock vertically, reliably, year after year. The emphasis on automation and conveyors reflects a broader industry shift. Deep mines are no longer labor-heavy operations defined by hundreds of workers underground at any given time. They are capital-heavy systems optimized for consistency. Fewer people underground means lower risk and more predictable output. It also means higher upfront costs. The machines do not come cheap, and neither does maintaining them at depth. This is where the Woodsmith project starts to look less like a green showcase and more like a traditional industrial gamble. The technology is proven, but the scale is unforgiving. Every shaft, every hoist, every conveyor must work as planned to justify the investment. There is little room for half measures. The mine cannot operate at small scale and gradually grow. It must function as a system, or not at all. In that sense, the engineering beneath North Yorkshire tells a more honest story than the barns above it. This is not about hiding industry. It is about committing to it fully, accepting the costs and risks that come with operating one of the deepest and most complex mines in Europe, and betting that long-term demand will reward that commitment. The real spine of the Woodsmith project is not the shafts, but the tunnel that turns a remote mine into a global exporter. From the extraction shafts, the polyhalite does not move by truck or rail. It moves through a single underground artery. A concrete-lined tunnel stretching roughly 37 kilometers from the mine site to the processing facilities on Teesside. This tunnel is not a supporting feature. It is the business model. At around 5 meters in diameter and buried hundreds of meters below ground, the tunnel houses what has been described as the longest continuous conveyor system in the United Kingdom. Its purpose is brutally efficient. Ore leaves the mine, enters the conveyor, and travels directly to the materials handling facility without ever touching the surface. No trucks, no road congestion, no visible emissions. For a project operating inside a national park, this was not optional. It was the only politically survivable option. Recent construction updates show why this tunnel keeps drawing attention in engineering circles. Tunnel boring machines weighing roughly 2,000 tons each were deployed from multiple access points, advancing at an average rate of about 20 meters per day. By late 2024, the excavation had passed the 30-kilometer mark, placing the project among the longest mineral transport tunnels ever built in Europe. Each meter board was immediately lined with prefabricated concrete segments, locking in structural integrity as the machines advanced. The cost reflects the ambition. The tunnel alone carries a price tag measured in multiple billions of dollars, making it one of the most expensive single pieces of infrastructure in the entire project. Supporters argue that this cost is justified because it eliminates decades of surface transport expenses and environmental conflicts. Critics respond that it concentrates risk. If the tunnel fails or underperforms, the entire mine feels it instantly. At the far end of the tunnel sits the Wilton Materials Handling Facility, where the polyhalite is crushed and granulated. There is no chemical processing stage. The ore's high natural purity allows it to move straight into final product form. From there, another enclosed conveyor system carries the fertilizer through a dedicated pipeline toward the port on the River Tees, where bulk ships can load directly for export. This is where Woodsmith starts to look less like a mine and more like a logistics machine. The extraction, processing, and shipping stages are designed as one continuous flow. Break that flow, and output collapses. Maintain it, and the system can push millions of tons per year with relatively low operating friction. For Anglo-American, this design reflects a hard-earned lesson from global mining. Scale only works when logistics are invisible and relentless. The tunnel is not glamorous, but it is the reason the project exists at all. Without it, the mine would be trapped by geography and regulation. With it, a hidden deposit under a national park becomes a permanent fixture in global fertilizer markets. By the time the Woodsmith project reaches full operation, it will no longer make sense to describe it as a hidden curiosity. On paper, the mine is designed for annual output measured in the tens of millions of tons, with internal planning scenarios clustering around the low double-digit million range per year once the system is fully ramped up. That level of production places it firmly among the most significant fertilizer-related mining projects in the world, not because of novelty, but because of endurance. Anglo-American's own messaging over the past 2 years has become noticeably more cautious and more revealing at the same time. The company has slowed capital spending, stretched timelines, and emphasized disciplined execution rather than rapid scale-up. This is not a sign of retreat. It is an admission of reality. Projects of this size do not fail because the geology is wrong. They fail because costs outrun patience, markets shift, or financing assumptions crack under pressure. The decision to phase investment and delay final ramp-up is a hedge against exactly those risks. The economics are straightforward but unforgiving. The mine requires sustained global demand for multi-nutrient fertilizer, stable shipping routes, and pricing that supports a capital base running into the many billions of dollars. In return, it offers long-term supply security, predictable output, and a product positioned as lower carbon compared to chemically intensive alternatives. This is not a growth stock story. It is an infrastructure story disguised as a mining project. There is also a political dimension that deserves attention. Britain often speaks about strategic resilience, supply chain independence, and green transition, yet rarely commits to projects that test those slogans over multiple decades. Woodsmith does exactly that. It locks the country into a long-term industrial path that cannot be unwound quietly. Once the tunnel, shafts, and port logistics are fully operational, walking away is not an option. That commitment cuts both ways. It can anchor regional employment and exports, or it can become a reminder of how expensive long-term bets can be when assumptions change. What makes Woodsmith unusual is not just its depth or invisibility, but its timing. It is being built in an era obsessed with speed, software, and short returns. This project offers none of that. It offers slow extraction, heavy capital, and payoff measured in decades. In a sense, it is almost an act of defiance against modern economic impatience. Whether this mine becomes a quiet success story or an uncomfortable lesson will depend less on engineering and more on discipline. The geology is generous. The technology is proven. The remaining variable is execution in a world that rarely rewards waiting. Britain is betting that this time, waiting will pay. Thank you for listening, and let us know what you think about this project and its implications by leaving your thoughts in the comments section.